twice, or two dice are thrown. Just give me a few seconds. Are thrown together. Then outcomes. Then outcome. See, we can get one on first die, one on second, one on first, two on second, one on first, three on second, one on first. And now we will take when we have number two on second die, and we will take rest of from 1 to 6 on second, okay? Similarly. Are you getting me?
Yes, ma'am.
Okay. So, first of all, we'll take one on first together with all on second. Then second on first die and all other numbers on the second die. And one by one, we'll take till 6. Okay. So let us find all outcomes. 3, 4, 3, 5, 3, 6. 4, 1 and 4, 2. Total we will have 26. So 36. These are total 36 outcomes when we toss a dice twice, either and or if we toss two, throw two dice. So they'll ask you a question like this: find the sum. Uh, like find the sum as 2 on both dice, sum as 6 or 8 or any like minimum it can be 2 and maximum it can be 12. So they can give you between them. Okay. So let us do one by one. We are doing for all. They'll give you a few out of them. Okay. So
Yes, ma'am.
probability to get sum 2 is equal to, see, we have only one favorable outcome to get some one comma, sorry, 2, which is 1 comma 1. So favorable is 1, total we have 36. Okay, next. Now we can find for sum as 3. Just few seconds. Now we will find probability to get sum, and we can write to get sum on both dice. To get sum 3 on both dice. Let us see how many favorable outcomes are there. So we have two outcomes to get sum 3, 2 comma 1 and 1 comma 2. Okay, so we have two favorable outcomes. So let us take 2 by 36, and that is equal to 1 by 18. Okay, so next. Now we will find probability to get sum 4 on both dice. So let us see outcomes. How many favorable outcomes? See, 1 comma 3 we can take, and sorry, 2 comma 2, not 6. 2 comma 2 and 3 comma 1. Okay, so we have 3 favorable outcomes. Three over 36. So we have 1 by 12. Now let us find probability get sum 5 on both sides. Let us see how many favorable outcomes we have to get 5, See, we have 1, comma 4, 1, comma 4, 2, comma 3, 3, comma 2, and 4, comma. We have 4 outcomes. So let us take this. 4 over 36. So 1 upon 9. Now let us find probability to get some 6. And one more thing, I have a book, okay, to do practice, and I'll share you, okay?
Okay, ma'am.
Yeah, I have a book for stats and probability, so I'll share you.
Ma'am, you can send it in WhatsApp because I think the email is having problem.
Okay. Sure. To get some 6. So, we don't need to see every time. Just we can take it as like 5, comma 1, 1, comma 5, 3, comma 3, 4, comma 2, 2, comma 4. Obviously, we have 5 favorable outcomes. You got?
Yes, ma'am.
Fine. Next. Probability to get some 7. Or we can take it as like 1, comma 6, 6, comma 1, 2, comma 5, 5, comma 2, 3, comma 7, sorry, 3, comma 4, 4, comma 3. So we have 6 favorable outcomes. By 6, so we have 1 by 6. Probability to on both price. It on both price. So for to get 8, let us count 1, 2, comma 6, 6, comma 2, and 5, comma 3, 3, comma 5, 4, comma 4. So we have 5 up. Now let us find probability to get some 9 on both dice is equal to, let us count to get 9, or like 3, comma 6, 6, comma 3, 5, comma 4, 4, comma 5. We have these. It means 4 outcomes. And total we have 36. So we have 1 by 9. Now let us find next probability to get some 10 on both dice. 4, comma 6, 6, comma 4, or 5, comma 5. So we have 3 outcomes. Sorry, 2. Yes, sir. Yes. 1 by 12. Next, probability to get some 11 on both dice. So 5, 6, 6, 5. We have two outcomes. So we have 1 by 18. And probability to get 12, obviously we will have 1 by 36. Well, on both dice is equal to 1 by 36. You got each and every step? You got or want to ask
Yes,
anything?
ma'am.
Okay,
No, ma'am.
all right.
Ma'am, why are you writing this on both dice?
Pardon?
Can you explain why you're writing this
Yes, yes,
probability to get some
yes.
12
Yeah,
on both dice?
yeah, I'm telling you why we write here. See, if you are taking this condition, if you take second condition, or two dice are thrown together, then we write on both dice because we are taking some which we got on both dice. Okay, because these are outcomes together. Okay, if you are taking both dice together, and or if a dice is thrown twice, so you will write here on both, like in both throws. Okay, or both
Okay, ma'am. Got it.
trials. Both you can say both trials also. Okay, in a stage of dice
Okay, ma'am.
because we are taking some on both. That is why we can say on both die or on both trials. Got it now?
Yes, ma'am. Got it.
Yeah. Next topic is second. So you got meaning of probability random experiment. This is random experiment where we throw two dice together. Sample space, when we take these entire sample space in a set like this. If we take these entire uh, outcomes, then we can take this as sample space. As is equal to write these all outcomes in the form of set. You got?
Yes, ma'am.
Good. And next, events and algebra of events. Okay, let us do these topics. Events. Okay, so events, we'll do later types of events and what it mean by event, like when we throw a die to get any number out of the six, that is an event. Like to get number 5 is an event. To get number 4, that is an also event. Okay. So in random experiment, whatever we get, if we get like in toss of coin, if we get hat, then to get hat is an event. Are you getting me?
Yes, ma'am.
Okay. So let us do event and algebra of events and further we will do. Because next topic we have done already, probability classical. That day we have done that formula. By using that, we are doing these parts here. This is by using classical definition. Okay, like number of favorable cases divided by total number of
Yes,
cases or
ma'am.
outcomes also.
Yes, ma'am.
Okay, so classical probability is just number of favorable outcomes is divided by total number of outcomes. So we have done this already. So now let us do events and algebra of events. because according to types of event, we have a probability. So just few seconds. Just few seconds. Hmm. Event in probabilities. Any subset of sample space is said to be an event. Any subset of sample space is said to be and we can define as let S be a sample space and E be a subset of sample space S, or we can say E be subset of S, then E is an event. Okay. Now, let us do algebra of events. Now, let us do algebra of events. First, we have complementary event. Second, the event A or B. We will choose any one of them. Third, the event A and B. And fourth is the event A but not B. Okay. So now we will do one by one, all of these types. Let us start. Let A, B, C are events associated with an experiment whose sample space, I'll explain you, okay? Each and everything. Whose experiment. So with an experiment whose sample space is S, such that A is subset of S, B is subset of S, and also C subset of S. Now let us do first type, complementary. Sorry. Complementary events. Let A dash B complementary event of A. Then it must be like we can define it as A dash is equal to S minus A. Like just subtract all those outcomes which occur in A, okay, from S. Then rest of you will get in A dash, which is complementary event of A. For example, uh, if we have in sample space, when we throw a die, we have outcomes into 6. If A is having even numbers, then A dash will be we'll have 1, 3, and 5. Then complementary event will have odd values. Okay, you got this?
Yes, ma'am.
Okay. Or we can define it as A dash is equal to X such that X belongs to S, but X not belongs to A. Okay. Either we can define it as A dash is equal to S minus A, or we can define by using this. Got it?
Yes, ma'am.
So let us rejoin once, then we'll do, okay? Let us rejoin once. Because meeting will be over.